Picture yourself standing before the Great Pyramid of Giza at dawn. The ancient stones, weathered by millennia, catch the first rays of sunlight as they have for over 4,500 years. You're not just looking at a monument. You're witnessing humanity's greatest unsolved mystery, a testament to human ambition that defies everything we think we know about ancient engineering. These aren't just tombs. They're impossible dreams made manifest in stone. The numbers alone should make your head spin. The Great Pyramid originally soared 481 feet into the Egyptian sky, constructed from an estimated 2.3 million limestone blocks. Each block weighs between 2.5 and 15 tons on average, though some of the granite slabs forming the king's chamber ceiling tip the scales at a staggering 25 to 80 tons. To put this in perspective, imagine moving your car without wheels, pulleys, or even iron tools. Now imagine doing it 2.3 million times, with surgical precision, in less than 3 decades. But here's where the story becomes truly haunting. Recent studies reveal that ancient Egyptian workers maintained a construction pace of 180 blocks per hour during 10-hour workdays. That's 3 massive stone blocks positioned perfectly every single minute, day after day, year after year. Modern construction crews, with all our technology, struggle to match this rhythm. The precision achieved by these ancient builders borders on the supernatural. When surveyors measured the Great Pyramid's base in modern times, they discovered something that sent chills through the engineering community. The entire 13.1-acre foundation was leveled to within a fraction of an inch. This accuracy rivals what we can achieve today using laser leveling technology. How did workers armed only with copper chisels, wooden levers, and rope accomplish what challenges our most sophisticated equipment? The mystery deepens when you consider what these builders didn't have. No wheels existed in their toolkit, making transportation a logistical nightmare. No pulleys assisted in lifting those massive blocks skyward. Iron tools remained unknown, leaving them to shape granite with copper implements that required constant resharpening. Yet somehow they achieved architectural perfection that has withstood earthquakes, wars, and the relentless march of time. The entire Giza complex represents an even more staggering achievement. 3 massive pyramids, the enigmatic Sphinx, elaborate temple complexes, boat pits carved from solid bedrock, and stone causeways were all constructed during a frenzied building period spanning just 60 years under 5 pharaohs. It's as if an entire civilization suddenly discovered the secret to moving mountains and decided to prove it to eternity. Modern technology continues to reveal new secrets hidden within these ancient giants. The Scan Pyramids project has been using cosmic ray imaging since 2015, detecting previously unknown chambers and passages sealed for millennia. In 2017, they discovered a void rivaling the size of the Grand Gallery, and more recently, a passage dubbed the North Face Corridor. These aren't random spaces but carefully engineered voids that distributed the enormous weight of millions of tons of stone, preventing catastrophic collapse. Yet, for all our satellites, computers, and particle physics, we still can't definitively answer the fundamental question: how were they built? Every proposed theory encounters problems that make engineers shake their heads in frustrated admiration. The massive ramps required by traditional theories would have consumed more stone than the pyramids themselves, yet no trace of such structures exists. Alternative theories involving internal ramps, water power, or lost technologies each solve some problems while creating others. Standing before these monuments today, you're confronting more than ancient architecture. You're face to face with the humbling reality that our ancestors possessed knowledge and capabilities that we're still struggling to understand. These pyramids don't just challenge our assumptions about the past. They force us to question what we think we know about human potential itself. The Great Pyramid remained the tallest human-made structure on Earth for nearly 4,000 years, until modern skyscrapers finally surpassed it in the 19th century. But height alone doesn't capture its true significance. This is engineering poetry written in stone, a message from the dawn of civilization that still makes us wonder, what else were they capable of that we haven't discovered yet? As we embark on this journey through the latest theories and discoveries surrounding pyramid construction, remember that you're not just learning about ancient building techniques. You're exploring one of humanity's greatest achievements, a mystery that connects us across millennia to people who dared to build the impossible and somehow succeeded. The stones are waiting to tell their story. The question is, are we finally ready to listen? Forget everything Hollywood has burned into your imagination. Forget the whip-cracking overseers driving emaciated slaves under the scorching desert sun. Forget chains, desperation, and forced labor-building monuments to pharaonic cruelty. The truth about who built the pyramids is far more extraordinary than any Hollywood fiction, and it reveals something profound about human nature that will change how you see these ancient marvels forever. The lie began with the ancient Greeks. Writing centuries after the pyramids were completed, historians like Herodotus spun tales of enslaved masses toiling under brutal conditions. For over 2 millennia, this narrative took root so deeply that even today, most people accept it without question. But archaeology has a way of shattering comfortable myths, and in 1990, a discovery near the pyramids rewrote history. Hidden beneath centuries of sand, archaeologists uncovered something that made them question everything they thought. They knew entire villages where the pyramid builders actually lived. Not slave quarters filled with misery and chains, but a thriving temporary city sprawling across 17 acres, complete with bakeries producing thousands of loaves daily, butcher shops processing massive quantities of meat, and breweries churning out beer by the barrel. The bones tell a story that Hollywood never imagined. These weren't the remains of malnourished slaves. These were well-fed, well-cared-for skilled workers whose diet included abundant meat, fresh bread, and beer. The sheer quantity of animal bones discovered suggests these builders ate better than most people in the ancient world. Someone was investing enormous resources not in oppressing these workers, but in keeping them healthy, fed, and motivated. The graffiti they left behind transforms these anonymous builders into real people with names, personalities, and pride in their work. Carved into stone blocks throughout the pyramids, archaeologists found inscriptions from work gangs with names like Friends of Khufu and Drunkards of Menkor. These weren't the desperate scratches of enslaved people marking time until death. These were proud signatures of craftsmen boasting about their contributions to something magnificent. Technical analysis reveals the sophistication of their organization. The workforce operated in Zhao, groups of 40 men subdivided into 4 teams, each led by an overseer of 10. This wasn't random mob labor. This was military precision logistics applied to construction, with hierarchies, specializations, and systematic approaches that would impress modern project managers. Recent estimates suggest the core workforce included around 20,000 to 30,000 people, but this number swelled dramatically during peak seasons. The revolution in understanding came when archaeologists realized these workers weren't full-time pyramid builders. They were part of a sophisticated labor system that functioned like a national service program. Communities across Egypt contributed workers, food, and materials as a form of taxation. Young men might spend weeks or months working on the pyramids before returning to their farms, their service complete. This wasn't slavery. This was civic duty transformed into something approaching a national project. Evidence from Middle Kingdom. Pyramids reveals even more complexity. Papyri records mention foreign workers from Canaan employed alongside Egyptians, suggesting the pyramid projects attracted skilled craftsmen from across the known world. These weren't prisoners of war or enslaved peoples, but specialists whose expertise was valued enough to transport them hundreds of miles. The emotional impact of this revelation runs deeper than historical correction. For generations, people have looked at the pyramids and seen monuments to oppression, testaments to what rulers could accomplish by crushing human spirits. The truth reveals something far more inspiring. These are monuments to human cooperation on an unprecedented scale, achievements that required not just royal power, but genuine collaboration between tens of thousands of people working toward a shared vision. Consider the logistics that made this possible. Coordination required feeding 30,000 people daily in a desert environment. Supply chains stretched across Egypt, bringing limestone from local quarries, granite from Aswan 600 miles south, and timber from Lebanon across the Mediterranean. The organizational capability needed to manage these operations rivals modern multinational corporations, yet it was accomplished using only human messengers, papyrus records, and careful planning. The work itself demanded incredible skill. Modern attempts to replicate pyramid construction techniques consistently fail, not because ancient workers were superhuman, but because they possessed specialized knowledge developed over generations. Stone cutting, transportation, and placement required techniques passed down through master-apprentice relationships, refined through decades of experience. These weren't unskilled laborers following simple instructions. These were the ancient, world's equivalent of aerospace engineers. Recent discoveries continue reshaping our understanding. The 2013 discovery of papyri at Wadi el-Jarf includes logbooks from Inspector Merer, who led teams of sailors transporting materials to Giza. His records reveal a world of professional pride, careful accounting, and systematic operations that speak to workers who understood they were part of something extraordinary. Perhaps most remarkably, evidence suggests these workers took pride in their accomplishments that transcended their individual contributions. They were building something intended to last forever, and they knew it. The precision of their work, the care in their construction, and the pride in their graffiti all speak to people who understood they were creating wonder for future generations. As you look at the pyramids now, see them not as monuments to oppression, but as testaments to what humans can accomplish when they work together towards something greater than themselves. These stones weren't raised by broken spirits, but by skilled hands guided by shared purpose. The question that emerges from this revelation is equally fascinating. If the workforce was willing and skilled, how did they overcome the seemingly impossible technical challenges of moving millions of tons of stone with Bronze Age technology? Imagine if the greatest mystery in human history could be solved by something as simple as water. For generations, engineers have tortured themselves trying to figure out how ancient Egyptians moved blocks weighing as much as modern trucks across desert sand and up hundreds of feet into the sky. They've proposed massive ramps, complex pulley systems, and elaborate lifting mechanisms. But what if the answer was hiding beneath our feet all along, buried under thousands of years of shifting? Sand and forgotten time? In 2024, satellites peering through the desert floor revealed a secret that changed everything we thought we knew about pyramid construction. Using radar imaging that can penetrate sand and sediment, researchers discovered the ghost of a river that once flowed directly past the pyramids of Giza. This wasn't just any stream. The Ahramat Branch, as archaeologists named it, was a massive waterway stretching 64 kilometers along what is now dry desert, connecting the pyramid sites to the life-giving Nile. Picture the scene 4,500 years ago, where today you see endless sand punctuated by ancient stones. There once flowed a river highway bustling with activity. Massive barges loaded with limestone blocks from Tura quarries floated downstream like ancient cargo ships. Granite slabs weighing tens of tons, quarried from Aswan 600 miles to the south, rode the current toward their destiny as pyramid stones. The Nile wasn't just Egypt's lifeline for agriculture and trade. It was the secret weapon that made the impossible possible. The emotional weight of this discovery cannot be overstated. For over a century, archaeologists have searched in vain for the massive earthen ramps that traditional theories demanded. These hypothetical ramps would have required more material than the pyramids themselves, yet no trace of them exists. The absence of evidence has haunted Egyptologists, forcing them to question whether they fundamentally misunderstood ancient Egyptian capabilities. The river theory doesn't just solve a technical puzzle, it heals a wound in our understanding of the past. But the ancient Egyptians didn't simply wait for nature to provide transportation. They engineered their own hydraulic miracles. Evidence suggests they dug specialized canals connecting quarries directly to construction sites, creating artificial waterways that could float massive stones right to where they were needed. These weren't crude ditches scratched in the sand. These were sophisticated engineering projects that demonstrate a mastery of hydraulic principles that we're only beginning to appreciate. The technical brilliance becomes clear when you understand the timing. The Nile's annual flood, lasting roughly 4 months each year, transformed the river into a powerful transportation network. During this period, water levels rose dramatically, extending navigable waterways far inland. Ancient engineers timed their quarrying and transportation to coincide with these floods, essentially using the river as a massive hydraulic lift system powered by nature itself. Consider the logistics this solved. A single limestone block weighing 15 tons would require 300 men to drag across sand using ropes and wooden sledges. The same block floating on a reed boat or inflated animal skin raft could be moved by a handful of workers. Multiply this efficiency by 2.3 million blocks, and the difference between possible and impossible becomes crystal clear. The river didn't just make pyramid construction easier, it made pyramid construction achievable. The human story behind this discovery touches something deep in our understanding of ancient ingenuity. In 2013, archaeologists discovered papyrus fragments at the ancient Red Sea port of Wadi el-Jarf that included logbooks from Inspector Merer, a middle-ranking official, who led teams of sailors during the 27th year of Khufu's reign. His careful records detail the movement of limestone from Tura quarries to the pyramid site, describing a sophisticated operation involving specialized boats, coordinated teams, and precise timing. Reading Merer's logbook is like discovering a voice from the past speaking directly about the pyramid's construction. He writes not as someone struggling with an impossible task, but as a professional managing a complex but well-understood operation. His entries describe working with Ankhyef, Khufu's half-brother and vizier, who oversaw the entire construction project. These weren't desperate improvisations. These were established procedures refined through experience and passed down through generations of builders. The technical sophistication required for water transport staggers modern engineers. Ancient boat builders had to create vessels capable of carrying enormous weights without breaking apart in river currents. They developed specialized rafts using cedar wood imported from Lebanon at enormous expense. They learned to use inflated, animal skins wrapped in papyrus as flotation devices, creating surprisingly effective cargo carriers that could be dismantled and reused. But perhaps the most ingenious aspect was the integration of water transport with the construction process itself. Evidence suggests that wooden rafts used for transportation were later repurposed as sledges for the final positioning of stones. The same cedar logs that floated blocks down the Nile became the rollers and levers needed to maneuver them into precise positions within the pyramid structure. The seasonal nature of this system reveals profound insights into ancient Egyptian planning capabilities. Construction had to be coordinated, not just across space, spanning hundreds of miles from quarries to building sites, but across time, synchronizing with annual flood cycles that couldn't be controlled or predicted with perfect accuracy. This required the kind of long-term strategic thinking that we associate with modern megaprojects. Yet challenges remained that even water power couldn't solve. The river could bring stones to the base of the plateau, but somehow, these massive blocks still had to be lifted hundreds of feet skyward to form the pyramid's upper reaches. Gates and pools controlled the movement of blocks from moats to building sites, but the final ascent remained a mystery that would require solutions even more ingenious than floating stone highways. As you envision the ancient Giza plateau alive, with river traffic, boat crews, and floating stones, you're witnessing more than just an engineering solution. You're seeing human beings who looked at seemingly impossible challenges and found ways to work with nature rather than against it. The question that haunts us now is equally fascinating. If water solved the transportation puzzle, what innovative force lifted these massive stones from river level to the pyramid's soaring heights? What if everything we thought we knew about ancient Egyptian technology was catastrophically wrong? What if these ancient builders weren't primitive people struggling with Bronze Age limitations, but hydraulic engineering masters whose sophistication we're only beginning to glimpse? The evidence emerging from recent studies doesn't just challenge our assumptions about pyramid construction, it shatters them completely, revealing a level of technological mastery that forces us to rewrite the story of human civilization itself. The revelation began in 2024 when researchers studying the step pyramid of Djoser made a discovery that sent shockwaves through the archaeological community. Half a century before the famous pyramids of Giza were even conceived, Pharaoh Djoser's architect Imhotep wasn't just stacking stones. He was orchestrating the world's first industrial-scale hydraulic engineering project, using water power to accomplish what should have been impossible with the technology of his era. Picture yourself standing beside the step pyramid today. seeing not just ancient stones, but the remnants of a water treatment facility more sophisticated than anything historians imagined possible. The mysterious structure known as Giza el-Mudir, long dismissed as a simple enclosure wall, reveals itself as something far more extraordinary, a massive check dam designed to trap and regulate water flow with the precision of modern hydraulic engineering. The emotional impact of this discovery cuts deep into our understanding of human progress. For generations, we've told ourselves a comfortable story about technological advancement, that it progresses linearly, that ancient peoples were necessarily primitive, that complex engineering is the exclusive domain of modern civilization. The hydraulic pyramid theory doesn't just challenge these assumptions, it obliterates them, forcing us to confront the humbling possibility that our ancestors achieved things we still don't fully understand. The technical details read like science fiction. Surrounding the step pyramid, archaeologists identified what they call the dry moat, a sophisticated water management system featuring sedimentation basins and purification facilities that controlled water quality with remarkable precision. This wasn't a simple ditch filled with Nile water. This was an integrated hydraulic network that cleaned, filtered, and channeled water to specific locations within the pyramid complex. But the most revolutionary aspect lies within the pyramid itself. Inside Djoser's monument, stone corridors angle upward from a central shaft in patterns that suggest something unprecedented. A hydraulic lift system powered by water pressure. The ancient architects, according to this theory, raised massive limestone blocks in a volcano fashion from the pyramid's center, using sediment-free water to create a liquid-powered elevator that could float stones skyward tier by tier. Though, implications stagger the imagination. Traditional ramp theories require thousands of workers hauling blocks up increasingly steep inclines, a process that becomes geometrically more difficult as pyramids grow taller. A hydraulic system could reduce the required workforce from 4,000 men at any given moment to perhaps a few hundred, transforming pyramid construction from a brute force operation into an elegant dance of engineering precision. Consider the profound shift in perspective this requires. Instead of viewing ancient Egyptians as people struggling against technological limitations, we must see them as innovators who solved complex problems by working with natural forces rather than against them. Annual Nile floods, traditionally seen as construction obstacles that halted work for months, become the very power source that made mega construction possible. The sophisticated water treatment system reveals knowledge that seems impossibly advanced. For its time, the Giza el-Mudir functioned not just as a dam, but as part of a unified hydraulics network that improved water quality and regulated flow for practical purposes. Water entering this system emerged cleaner, properly channeled, and ready for the precise engineering required inside the pyramid structure. Evidence suggests this hydraulic mastery developed in response to environmental challenges that modern engineers would recognize. Before the Fourth Dynasty, Egypt faced more problems with floods than drought. Annual inundations could swallow work sites, rot timber, and strand supplies for months. Ancient engineers didn't simply endure these floods, they harnessed them, converting surplus water into free labor that could accomplish what thousands of human workers could not. The transformation happened quickly once the technology was perfected. Stone sizes doubled within a generation. By the time Khufu's Great Pyramid rose at Giza around 2550 BC, individual blocks regularly exceeded 5 tons, with some massive granite slabs weighing 80 tons. Hauling such loads up traditional ramps would have required enormous crews and months of preparation. A water-driven lift could move the same stones with a fraction of the manpower and time. Yet the emotional weight of this discovery extends beyond technical admiration. It forces us to confront our own limitations in understanding the past. How many other ancient achievements have we dismissed as impossible simply because we couldn't imagine how they were accomplished? How many civilizations have we underestimated because their methods didn't match our expectations of technological development? The hydraulic theory also reveals something profound about human innovation under pressure. Faced with seemingly impossible construction challenges, ancient engineers didn't accept defeat. They observed their environment, identified available resources, and developed solutions that worked with natural forces rather than fighting them. This represents a kind of engineering wisdom that modern builders, with all our machinery and power, sometimes struggle to achieve. If this theory proves correct, it means the Step Pyramid wasn't just the world's first monumental stone building. It was the prototype for a construction technology so advanced that it enabled the golden age of pyramid building that followed. Imhotep wasn't just an architect. He was the world's first hydraulic engineer, solving problems that wouldn't be attempted again until the industrial age. The evidence continues mounting, but questions remain that could reshape our entire understanding of ancient capabilities. If 4,500-year-old engineers mastered hydraulic lifting systems, what other technologies did they develop that we've lost or never recognized? If these ancient engineering secrets fascinate you as much as they fascinate us, smash that subscribe button and ring the notification bell. We're uncovering history's greatest mysteries every week. What theory do you think is most likely? Drop your thoughts in the comments below, and don't forget to share this video with anyone who loves ancient history. The story of how these stones actually rose from ground level to soaring heights is just beginning to unfold. Stand at the base of the Great Pyramid and look up. 481 feet of precisely stacked stone blocks stretch toward the heavens, each one positioned with surgical accuracy that defies comprehension. Now imagine you're an ancient Egyptian engineer tasked with moving 2.3 million blocks up this impossible height, using nothing but rope, wood, and human muscle. How do you even begin to approach such a challenge without surrendering to despair? For over a century, archaeologists have grappled with this nightmare scenario, proposing solutions that seem almost as impossible as the original problem. The most enduring theory suggests massive ramps spiraling around or zigzagging up the pyramid faces, allowing workers to drag stone blocks skyward on wooden sledges. But here's the crushing reality. Such ramps would require more material than the pyramids themselves, yet despite decades of searching, archaeologists have found virtually no trace of these hypothetical structures. The absence haunts every pyramid. Researcher. You can see it in their eyes when they discuss ramp theories, a mixture of frustration and stubborn determination. They know the ramps must have existed in some form because no alternative explanation seems remotely plausible. Yet the evidence remains maddeningly elusive, like trying to prove the existence of ghosts by the absence of rational explanations. Enter Jean-Pierre Houdin, a French architect who did something unprecedented. He quit his successful career and devoted years to solving this puzzle using cutting-edge computer modeling. Working with the French software company Dassault Systèmes, Houdin developed the first fully functional CAD architectural model of the Great Pyramid, testing theories, with the precision of modern engineering software. His breakthrough proposal reads like elegant problem-solving poetry. According to Houdin's theory, builders used traditional external ramps for only the first 30% of construction, roughly 140 feet of height. Beyond that point, they employed an ingenious internal ramp system that spiraled upward inside the pyramid structure itself. Most remarkably, the stones from the external ramps weren't wasted. They were recycled into the pyramid's upper levels, explaining why no massive ramp remnants litter the Giza plateau today. The technical brilliance of this approach becomes clear when you consider the mathematics. A straight ramp reaching the pyramid's apex would stretch nearly 2 miles and require a slope gentle enough for workers to actually drag massive stones upward. Such a structure would consume millions of tons of material and dominate the landscape for miles around. Houdin's internal ramp system solves these problems while explaining the mysterious absence of external evidence. But testing ancient theories with modern technology revealed sobering truths about the limits of human endurance. Even with sophisticated ramp systems, the physical demands remained staggering. Experimental archaeology conducted by Mark Lenner and Roger Hopkins demonstrated that moving a 2-ton stone required 12 to 20 men using wooden sledges on wooden tracks. Scaling this up to 15-ton blocks means teams of 100 workers or more for each stone working in carefully orchestrated shifts to maintain the 3 blocks per minute construction pace that recent studies suggest. The lubrication techniques reveal ancient ingenuity born from desperate necessity. Modern experiments confirmed that wetting sand in front of wooden sledges dramatically reduces friction, making it possible to move massive loads with significantly fewer workers. But this seemingly simple solution required enormous logistical Coordination. Teams of workers had to constantly wet the sand along ramp surfaces, requiring sophisticated water distribution systems and careful timing to prevent the desert from immediately reclaiming moisture. Perhaps most sobering was the 1978 Japanese experiment that brought the theoretical challenges into stark reality. A team of 24 scientists attempted to build a miniature pyramid next to the real pyramids using only ancient methods and tools. Their failure was complete and humbling. Despite modern knowledge of physics, engineering, and construction management, they couldn't successfully cut, transport, and position stones using copper tools and human labor alone. The emotional weight of these failed attempts resonates deeply with anyone who has struggled against seemingly impossible odds. These modern scientists experienced firsthand the crushing difficulty that ancient workers faced daily for decades. The Japanese team had advantages the ancients lacked: detailed knowledge of the finished product, unlimited time for planning, and the ability to quit if the project became too challenging. Yet they couldn't accomplish what Egyptian workers achieved. Routinely 4,500 years ago, wood presented another hidden challenge that reveals the global scope of pyramid construction. The massive quantities of timber required for sledges, tracks, levers, and scaffolding couldn't be sourced locally. Egypt's limited forests couldn't supply the enormous wooden infrastructure that ramp systems demanded. Instead, cedar logs had to be imported from Lebanon at staggering expense, requiring maritime expeditions across the Mediterranean and complex trade relationships spanning hundreds of miles. The human cost of ramp construction becomes visceral when you consider the physical toll. Workers hauling blocks up increasingly steep inclines fought not just gravity, but exhaustion, dehydration, and the constant risk of crushing accidents. Yet somehow they maintained precision that rivals modern construction standards while working at a pace that modern crews struggle to match, even with mechanical assistance. Recent computer modeling has refined ramp theories while deepening appreciation for ancient engineering challenges. Digital simulations can test countless ramp configurations, optimizing angles, materials, and worker movements with mathematical precision. Yet every simulation reinforces the same humbling conclusion. Even the most efficient ramp systems required organizational capabilities and human endurance that stretch the boundaries of believability. As these modern investigations continue revealing the stunning complexity of ancient pyramid construction, one question becomes increasingly urgent. If ramps alone couldn't explain the pyramid's impossible precision and speed, what other innovative techniques did ancient engineers develop that we're still struggling to understand? Imagine holding a laser level in your hands, watching its red beam slice perfectly horizontal across a construction site, and knowing that your measurement is accurate to within millimeters. Now imagine achieving that same precision 4,500 years ago using nothing but rope, water, and human observation. The mathematical perfection of the pyramids doesn't just challenge our understanding of ancient capabilities. It forces us to confront a humbling truth. In some ways, these ancient builders were more precise than we are today. When modern surveyors first measured the Great Pyramid's base with sophisticated equipment, they expected to find the typical errors that plague ancient construction projects. Instead, they discovered something that sent chills through the engineering community. The entire 13.1-acre foundation was leveled to within a fraction of an inch across its massive expanse. To put this in perspective, imagine leveling a football field so perfectly that the highest and lowest points differ by less than the thickness of your thumb. This isn't just impressive for ancient times. This accuracy rivals what modern construction crews achieve using laser leveling technology, GPS coordinates, and computer-controlled grading equipment. The emotional impact of this discovery cuts deep into our assumptions about technological progress. How did workers armed only with copper tools, wooden levels, and careful observation achieve precision that challenges our most sophisticated machinery? The mathematical mysteries extend far beyond simple measurement. In 1859, Egyptologist John Taylor made a discovery that has puzzled mathematicians for over 150 years. The dimensions of the Great Pyramid encode the mathematical constant pi with startling accuracy. The ratio between the pyramid's perimeter and its height approximates pi so closely that it cannot be coincidental. Yet pi wasn't formally calculated by Greek mathematicians until thousands of years later. This revelation forces us to grapple with uncomfortable questions about the sophistication of ancient mathematical knowledge. Did Egyptian architects deliberately encode pi into their design, suggesting mathematical understanding far beyond what historians have attributed to their civilization? Or did they stumble upon this relationship through empirical trial and error, achieving mathematical perfection through intuitive design principles we've lost? The astronomical alignments reveal another layer of precision that borders on the supernatural. The pyramids aren't just randomly oriented structures. They align with cardinal directions so precisely that modern astronomers struggle to explain how ancient builders achieved such accuracy without sophisticated instruments. The Great Pyramid's sides align with true north to within 3/60th of a degree, a precision that requires accounting for the Earth's rotation and the movement of celestial bodies. Consider the emotional weight of standing inside the king's chamber, surrounded by granite blocks that fit together with tolerances measured in fractions of millimeters. These aren't roughly hewn stones stacked with primitive mortar. These are precisely engineered components that interlock with Swiss watch precision. The joints between stones are so tight that you cannot slide a knife blade between them, yet each block weighs multiple tons and was positioned without modern lifting equipment. The tool technology available to ancient builders makes their achievements even more staggering. Copper chisels capable of cutting limestone required constant resharpening, wearing down rapidly against hard stone. Workers had to maintain teams of specialists whose sole job was keeping tools sharp enough to continue cutting. Bronze tools, available later in the construction period, offered improvements but still paled compared to iron implements that wouldn't appear in Egypt for centuries. Yet with these supposedly primitive tools, ancient craftsmen achieved surface finishes that rival modern stonework. The original limestone casing stones, most now lost to time and theft, were polished to mirror-like perfection. The few surviving examples at the Bent Pyramid demonstrate finishing techniques so sophisticated that they reflect sunlight with the brilliance of polished metal. How do you achieve such surface quality using copper tools and sand abrasives? The water leveling techniques employed by ancient engineers reveal ingenious solutions to seemingly impossible surveying challenges. By creating water-filled trenches and using the water surface as a reference level, builders could establish horizontal baselines across enormous distances with remarkable accuracy. This technique, refined through generations of temple and pyramid construction, allowed workers to detect elevation differences that would challenge modern survey equipment. Recent discoveries using cosmic ray imaging technology have revealed internal precision that defies explanation. Hidden chambers and passages within the pyramids aren't random voids but carefully engineered spaces designed to distribute enormous structural loads. The weight of millions of tons of stone creates crushing forces that would destroy any structure not precisely engineered to handle them. Yet these internal support systems were invisible to builders, requiring them to calculate stress distributions and load paths using only experience and intuition. The quarrying precision demonstrates mastery of stone-cutting techniques that modern stonemasons respect and admire. Ancient workers didn't randomly hack blocks from quarry faces. They used sophisticated techniques involving wooden wedges, water expansion, and careful planning to extract blocks of specific sizes and shapes. The uniformity of pyramid blocks suggests quality control standards that rival modern manufacturing processes. Perhaps most mysteriously, the ancient builders maintained their extraordinary precision while working at impossible speed. Recent calculations suggest construction crews positioned 3 massive blocks every minute during peak construction periods, yet they never sacrificed accuracy for speed. Modern construction projects that attempt similar precision typically proceed at glacial pace, with multiple quality checks and engineering reviews for every component. The emotional resonance of this precision extends beyond technical admiration. It speaks to a mindset that valued perfection over convenience, permanence over efficiency. These builders knew they were creating something intended to last forever, and they invested whatever effort was necessary to achieve that goal. Every carefully aligned stone, every perfectly level surface, every precisely calculated angle represents a commitment to excellence that transcends individual lifespans. Standing before these monuments today, you're witnessing more than ancient architecture. You're seeing physical proof that human dedication and skill can achieve seemingly impossible goals when guided by unwavering commitment to precision. The question that haunts modern engineers isn't just how they achieved such accuracy, but whether we've lost something essential about the relationship between craftsmanship and human spirit. If ancient builders could achieve such mathematical and engineering perfection using Bronze Age tools, what does that tell us about the true limits of human capability when focused on worthy goals? Picture this: 24 of Japan's brightest scientists, armed with detailed knowledge of physics, engineering principles, and construction management, standing in the shadow of the Great Pyramid in 1978. They had one goal that seemed simple enough: build a miniature pyramid using only the tools and techniques available to ancient Egyptians. Their failure was so complete, so humbling, that it reverberates through archaeological circles to this day, forcing us to confront an uncomfortable truth about our own limitations. The Japanese team arrived in Egypt with confidence born from decades of studying pyramid construction theories. They understood leverage, friction coefficients, and load distribution. They had carefully planned their approach, calculated material requirements, and organized their workforce. Yet within days of beginning their experiment, they encountered obstacles that reduced grown men to frustrated bewilderment. The gap between theoretical knowledge and practical execution proved far wider than anyone had imagined. Their first crushing defeat came at the quarry. Using copper chisels to cut limestone blocks sounds straightforward in textbooks, but the reality devastated their timeline and morale. Copper tools dulled within minutes against hard stone, requiring constant resharpening that consumed more labor than the actual cutting. The team quickly discovered why ancient builders needed entire crews dedicated solely to tool maintenance. Without this support infrastructure, their small team couldn't maintain cutting tools sharp enough to make meaningful progress. The transportation phase revealed even deeper challenges that textbook theories hadn't anticipated. Moving stones weighing hundreds of pounds across sand using only ropes, wooden sledges, and human muscle power proved exponentially more difficult than calculations suggested. Sand constantly shifted beneath sledge runners, creating instability that threatened to crush workers. Rope fibers stretched and frayed under heavy loads, requiring constant replacement and careful monitoring to prevent catastrophic failures. But perhaps the most demoralizing discovery was the precision required for even basic stone placement. Ancient builders didn't just stack blocks randomly. Each stone had to be positioned with millimeter accuracy to maintain structural integrity and proper weight distribution. The Japanese team, despite their engineering expertise, couldn't achieve anywhere near the precision that ancient workers maintained while constructing monuments intended to last millennia. The emotional impact of their failure extends far beyond academic embarrassment. These were accomplished professionals who understood construction principles, had access to detailed archaeological research, and could study the finished pyramids for guidance. Yet they couldn't replicate what Egyptian workers accomplished routinely 4,500 years ago, while working under far more challenging conditions with inferior tools and no modern safety equipment. Mark Lehner and Roger Hopkins attempted a more systematic approach, building experimental structures to test specific pyramid construction techniques. Their work revealed sobering truths about the human cost of ancient construction. Even with modern shortcuts like iron tools and mechanical assistance for heavy lifting, their team struggled to maintain the pace and precision that ancient builders achieved daily. Their experiments demonstrated that moving a modest 2-ton stone required 12 to 20 men working in perfect coordination. Scaling this up to the 15-ton average blocks used in pyramid construction meant teams of 60 to 100 workers per stone, all moving in synchronized precision to avoid crushing accidents. The logistics of coordinating such massive teams while maintaining safety and efficiency challenges modern project management capabilities. The tool maintenance requirements alone would have overwhelmed most construction projects. Lehner and Hopkins discovered that copper tools required resharpening every few minutes of active use, necessitating approximately 20 additional workers dedicated solely to keeping cutting implements functional. This hidden labor cost multiplied the workforce requirements far beyond initial calculations, revealing why pyramid construction demanded such enormous human resources. Perhaps most humbling was their inability to replicate the precise stone jointing that characterizes pyramid construction. Despite unlimited time for planning and adjustment, modern builders couldn't achieve the tight tolerances that ancient craftsmen maintained while working under production pressure. The ancient builders possessed specialized knowledge developed through generations of experience, techniques passed down through master-apprentice relationships that modern archaeology has yet to fully decode. Computer modeling offers theoretical solutions that sound elegant until tested against physical reality. Digital simulations can optimize ramp angles, calculate load distributions, and model worker movements with mathematical precision. Yet every computer model relies on assumptions about human capabilities, tool performance, and material properties that may not reflect ancient realities. The recurring pattern in modern attempts reveals a profound truth about the nature of ancient knowledge. These weren't primitive people struggling with technological limitations. They were specialists who had refined their techniques through centuries of temple and monument construction, developing expertise that integrated seamlessly with their tools, materials, and environmental conditions. The failure of modern attempts also highlights what we've lost in our transition to mechanized construction. Ancient builders possessed intimate knowledge of stone properties, understanding how different limestone varieties behaved under stress, how granite could be shaped and positioned, and how wooden tools could be optimized for specific tasks. This knowledge couldn't be learned from textbooks or computer simulations. It required generations of hands-on experience working with the same materials under similar conditions. The Japanese experiment and subsequent failures force us to confront our own hubris about technological progress. We assume that access to modern knowledge automatically grants us superior capabilities, yet these attempts demonstrate that theoretical understanding differs fundamentally from practical expertise. Ancient builders possess something we've lost: deep intuitive mastery of their craft developed through lifelong dedication to perfecting specific skills. Standing before the pyramids today, knowing that modern attempts to replicate their construction have consistently failed, transforms how we see these monuments. They're not just impressive ancient buildings. They're proof that human capability, when focused and refined through generations of practice, can achieve things that seem impossible even to our technologically advanced civilization. What other ancient accomplishments are we underestimating because we can't imagine how they were achieved? After 4,500 years of weathering sandstorms, earthquakes, and the relentless march of civilizations, the pyramids of Giza continue to guard their deepest secrets. But today, we stand at the threshold of a new age of discovery, armed with technologies that would seem like magic to the ancient builders themselves. The question isn't whether we'll finally solve the pyramid mystery. The question is whether we're ready for the answers we might find. The Scanned Pyramids project represents humanity's most ambitious attempt to peer inside these ancient giants without disturbing a single stone. Since 2015, an international team has been using cosmic ray muography, a technology borrowed from particle physics, to map the hidden architecture within the pyramids. These cosmic rays, constantly bombarding Earth from deep space, reveal empty spaces and dense areas inside the structures with unprecedented precision. The discoveries have been nothing short of revolutionary. In 2017, researchers detected a massive void within the Great Pyramid that rivals the dimensions of the Grand Gallery itself. This hidden chamber, sealed for millennia, challenges everything we thought we knew about pyramid design. More recently, they've identified the North Face Corridor, a passage that may hold keys to understanding how the internal structure was engineered to support millions of tons of stone. The emotional weight of these discoveries transcends archaeological significance. Each new chamber represents a direct connection to the minds that conceived these monuments, preserved thoughts written in stone and space. Standing before the pyramids knowing that hidden rooms lie just beyond reach creates a profound sense of anticipation mixed with humility. We're closer than ever to understanding ancient intentions, yet each answer seems to generate new questions. Advanced satellite archaeology has revolutionized our understanding of the pyramid landscape itself. High-resolution imaging and ground-penetrating radar reveal features invisible to traditional archaeological methods. The discovery of the ancient Ahrimat branch of the Nile, buried beneath centuries of sediment, demonstrates how much of the pyramid story remains literally hidden beneath our feet. Artificial intelligence now assists in analyzing the vast datasets these technologies generate. Machine learning algorithms can identify patterns in stone placement, detect structural anomalies, and model construction sequences with computational power that would have astounded previous generations of researchers. Yet even our most sophisticated AI systems struggle to explain how ancient builders achieved such consistent precision across millions of individual stones. The integration of multiple research technologies creates a comprehensive picture that individual methods couldn't achieve. Cosmic ray imaging reveals internal voids, satellite archaeology maps external features, and AI analysis identifies construction patterns. Together, these approaches are painting the most detailed portrait ever assembled of how the pyramids were actually built. But perhaps the most profound realization emerging from current research is that multiple construction techniques likely work together rather than competing as exclusive solutions. Water transport solved material delivery challenges. Hydraulic systems may have lifted stones through internal passages. Ramp systems probably handled final positioning and external construction phases. The ancient builders weren't limited to single solutions. They were comprehensive engineers who employed whatever methods worked best for specific challenges. This integrated approach reflects a sophistication that modern megaprojects struggle to match. Contemporary construction typically relies on standardized methods applied uniformly across entire projects. Ancient pyramid builders demonstrated remarkable flexibility, adapting techniques to geological conditions, seasonal changes, and evolving architectural requirements. This adaptability may represent their greatest achievement, surpassing even the monuments themselves. The technological advances driving current discoveries continue accelerating at unprecedented pace. Future imaging technologies will provide even higher resolution views of internal structures. Robotics may eventually explore hidden chambers without disturbing ancient architecture. Virtual reality will allow researchers to walk through pyramid interiors as they existed during construction, experiencing ancient spaces that no human has entered for millennia. Yet technology alone cannot solve the pyramid mystery. The human element remains irreplaceable. Understanding ancient motivations, cultural contexts, and engineering philosophies requires insights that no amount of data processing can provide. The pyramid builders weren't just solving technical problems, they were expressing religious beliefs, demonstrating royal power, and creating symbolic connections between earthly and divine realms. The ongoing research reveals something profound about human curiosity itself. For over 150 generations, people have looked at these monuments and wondered how they were built. This continuous thread of inquiry connects us directly to every person who has ever stood before the pyramids and felt overwhelmed by their impossibility. We're part of an unbroken chain of human wonder stretching back to antiquity. The preservation. Challenges facing the pyramids add urgency to current research efforts. Tourism, environmental changes, and urban development threaten these irreplaceable monuments. Understanding their construction methods may prove crucial for developing conservation strategies that protect them for future generations. We're not just solving historical mysteries. We're racing against time to preserve the evidence before it's lost forever. The pyramid mystery also reflects broader questions about human achievement and technological development. If ancient builders could accomplish things we still struggle to understand, what other capabilities have been lost over time? How many other civilizations have developed sophisticated solutions to complex problems using approaches we haven't considered? Modern engineering continues learning from ancient achievements. Biomimicry applies natural principles to technological problems. Similarly, ancient engineering wisdom may offer solutions to contemporary challenges. The pyramid builders' ability to work with natural forces rather than against them provides models for sustainable construction that could revolutionize modern architecture. The emotional journey through pyramid research ultimately leads to a profound appreciation for human potential. These monuments prove that dedicated people working toward shared goals can achieve seemingly impossible things. The precision, scale, and permanence of the pyramids demonstrate what human civilization can accomplish when knowledge, skill, and vision align in service of something greater than individual ambition. Standing before the pyramids today, knowing what current research has revealed while recognizing